It's our last day of our final review for semester one. We're going to do numbers 21 through 25. Here we go. What type of exponential function is this? They made this a function, but one thing I'll show you is this might look more familiar right now. Um, I'm not going to show what's inside the parentheses because that's the key piece of the puzzle here. See if you remember what was in there originally, because right now we see 3.5. So give yourself a chance right now to answer growth or decay, and also the second question here. So what is originally in here is 1 either plus or minus the rate. Remember, if this number in parentheses is bigger than 1, then it was a plus. So we're talking about growth. Now, you can write all of these words. You don't need to, but you do absolutely need to write down this work here. So let's talk about it. We already talked about why it's growth, but what was the actual percent rate of change? So we're looking for a percent and we're looking for how much it changed. Now, the most common mistake is people see this as 3.5 right now and they go, oh, it's 3.5. I know as a percent, I move that decimal over two spaces, that's 350%. Well, that's not the case because what was originally in there? Well, it's 1 plus r. We just went over that. So the rate of change is whatever r was. Well, you could do 3.5 minus 1 to find out the difference, or just ask yourself, what would r have to be? What would 1 have to be added with to get 3.5? Now that's 2.5. And as a percent, that's 250% because we move that decimal over. 22. Give it a shot. Now let's see how you did. The length of a rectangle is 5. So let's highlight color coordinate here. The length of a rectangle is 5 inches longer than its width. So that's a relationship, right? They're related in that way. But what else? Well, they tell us the perimeter of the rectangle is 40 inches. You remember what perimeter is? Well, that's like you're taking a walk around the block, right? You start here, you go down, you're like, okay, I'm going to turn here, then I'm going to go just around the block and finish where I started. That distance around is the perimeter. And there's a formula for that, which you may discover just naturally, or you might remember. But there's one other key element here that we'll highlight. It says, write an equation in terms of width, W, that you can use to find the length and the width. Okay, so it says in terms of an equation in terms of W. So we want an equation with only the variable W in it. Well, right now we could just label L for length, W for width, take it one step at a time. Give yourself a try if you haven't already, and then we'll work this out together. So you could start out by labeling, they said length is 5 inches longer. So you may have started out by labeling this is length and this is width. And we want an equation with only W. So we'll get to that in a second. But for now, length, we could say is W plus 5 because they told us about that relationship. Width is just width. That's kind of like the base knowledge, and we're relating it to length here. Now, we talked about the distance around being the perimeter. Well, how far would you go? Well, you'd go W plus this far, W plus 5, plus this far, W, plus this far, W plus 5. So in other words, the perimeter equation is 2 times the lengths, because you have 2 lengths, plus 2 of the widths. That gives you the perimeter. And we already identified what the side should be. And the perimeter we were told up here is 40 inches. So what do? We substitute into this perimeter formula. So we take the W plus 5, we substitute that in. We were given the perimeter, we substitute that in, and now right here we do have an equation with only W's. From here, these are inverse operations you are very familiar with. You are distributing the 2 because ultimately you're solving for W. And this one's trapped in parentheses. Sorry, my dogs are barking. If they don't stop soon, I'll close the door. But you distribute that 2. Now the W here is free from parentheses. You have like terms here. You add those together. And now the W's are together, and we just have 2 inverse operations to do to solve for W. So we subtract and divide and find the width to be 7.5 inches. But they also want us to find the length, and we had a length equation here that looks pretty simple. So we use that here. Just plug in the width that we found, add that to 5, and you'll also find the length. And it should be longer than the width, which it is. So that's good. 23 is similar but different. That was a good time for you to practice. Okay. If you said B, good job. If you didn't, that's okay. Let's see where you went wrong here. A rectangular crate, we draw the rectangle, holds 72 bottles. So we're talking about 72 bottles inside. Think back to geometry. What term defines the area or the space inside? Well, I just said it, didn't I? It's the area. So the area is 72, and we're talking about terms of bottles. In terms of bottles, I should say. The rows across the width of the crate hold 1 bottle less than the rows across the length. So you could start out by labeling this as W and this is L. I always label the longer side as the length, shorter side as the width. But we want them to be relatable, right? So instead of L and W, I'm going to set L equal to B, B for bottles, W equal to B minus 1. So far, this is very similar to the last problem. And then A is 72. We were told that up here. And the area formula is length times width. And we can use that formula to ultimately find out, what do they want to know? How many bottles are in the longer rows. Okay? And these are the longer rows, right? B, which is 1 longer than these. So what do? We need to solve for B. And that's why we have this all in terms of B. So we use our area formula. Area equals length times width. And we solve for B. Distribute, because this B is trapped. Then you have this, and you might be thinking, let's get everything away from B, but wait a second. We have a B squared minus B. What do we have there? Well, this is something you've seen and worked with many times throughout the year. We have ourselves a quadratic. I know it's not x, but it's a variable. B is a variable. So we need to solve this in terms of a quadratic, which requires factoring. We factor to then find the roots. Okay, so what do? You need everything on one side of the equal sign set equal to 0. So eventually we can apply the zero product property. So we have here a quadratic with a leading coefficient of 1, right? We don't see anything there, so we know it's 1. And if that's the case, we should be able to use the x method to find b. And we are. We are able to do that. You'll write the negative 72 and negative 1, and you'll look for factors that could somehow possibly multiply to negative 72 and add to negative 1. And we found that negative 9 and 8 do exactly that. So we plug them into our factors. Remember, this is usually x. So it looks a little different here, but in this case it's b. And then that negative 9 and 8 are there. And finally, we apply our zero product properties, setting each factor, b minus 9 and b plus 8, equal to 0, and solving. But notice the helpful hint here, it has to be a positive number because we're talking about a number of bottles in a crate. There's no way they'll be negative. So we have 9. So basically there will be 9 bottles in these columns and 8 in these rows. So we're talking about something like that. I'm not going to draw it all out precisely, but you get the idea. 24 and 25 are also similar to each other. So let's see what happens here. Solve. It says solve. What are we solving for? What's unknown? Obviously, we can see an x, which is good. There's only one x, and there's some helpful clues on the board. Did you get A as an answer? Let's see why it's A. So we have an absolute value inequality. The number one thing we need to do always with these is get the absolute value by itself. So you don't want this 7 here. And 7 is touching, right? We don't see a plus or a minus or anything else. So remember in math, touching always means multiply. Inverse is divide. Now we have the absolute value isolated. And don't forget this rule too. If this was negative, you divide by a negative and this inequality sign would change. It would flip. That doesn't happen here, but it could in different problems. So an absolute value, what does it mean to have an absolute value? Well, let's talk about absolute value of 5. Well, that could be 5. It could also be negative 5, right? Think about a number line. Absolute value is distance away from 0. 5 is there, negative 5 is there. These are both 5 away from 0, right? So that's why we need two different cases for these. And here's how you handle them in case you forgot. For the positive case, you need to remove the absolute value signs. So they are gone, and that's it. Everything else stays the same, just solve for x. So we use inverse operations once again, add, divide, there's one answer. Got it. For the negative case, you need to remove the absolute value signs again, but two other things need to happen. You need to flip that inequality sign to face the other way and make whatever is on the right side here negative. That's the difference. But then everything else is the same. Use the inverse operations. Add, divide. You get your second answer, which we see here. So that's all good. Last problem, here we go. You weren't asked to graph on 24, but you are on 25. So it's solved the same way, but then you want to graph it. And interestingly enough, you could actually get the right answer for this problem without even solving or doing any work. We are going to do work, but do you see how you could do that? It's all about this inequality sign. That is not or equal to, which means what? Open dots only, no filled in dots. So it has to be C because this is the only option with two open dots. But let's see how it became, because it's not always going to be that obvious, but that is something to look out for. Once again, isolate the absolute value. There it is. Positive case, right? Splitting into two cases, remove the absolute value, solve for x. At this point, I would graph this. And you're graphing where the x's are. X is less than 7, so 7 is not included, open dot, and x is less than. So when I'm starting to graph this, I would just kind of go like this, because I don't know what's happening here yet. I need to work it out. So I'm not going to draw a line all the way over, just an arrow indicating that it's going in that direction. Once again, the negative case, remove absolute values. Do you remember what else to do? It also says it here. Flip that inequality sign. It was facing left. It's now facing right. And make that positive 4, negative. Add, and we get x is greater than negative 1. So we find negative 1. Once again, open dot. And x is greater than, so we're shading to the right. So I would go like this. And then I know that these are going to connect, right? The arrows are going in the same direction. So they will collide, giving you this blue graphed line here. You've done it. You finished the final review. It's now time to study, practice, fill in your notes in any way you can, anything you missed, and study. You will do well. These dates here are different depending on the year you're watching this recording, but check your announcements. We'll have all of your end of semester deadlines, unless you already know them, of course. But study, take the final when you're ready. Remember, it's one try, but you don't have to do it all at once, and you can have this practice final right there with you to guide you every step of the way.